Hello, I'm Stephen Foskett, and we are here in San Francisco, California for Cloud Field Day. We're at the offices of Scality, and we've invited in a group of independent writers, speakers, podcasters, and so on to learn about their technology, to interact during the presentation, and to ask questions that represent the audience outside. If you'd like to learn more about Tech Field Day, go to techfieldday.com. You can learn how to become a delegate like the folks around the table or a presenter like Scality. If you'd like to see more videos like this, just go to youtube.com/techfieldday.
So I'm Giorgio Regni, CTO and one of the founders of Scality, and we're going to talk about our new S3 connector that we designed for the enterprise. So it's a new development that we've started a year ago to redo our S3 connector. We want to focus on ease of deployment, and we're using Docker for that. We really wanted to focus on multi-tenancy. Because a lot of our customers are asking for one large storage that they can share between departments and between users. And for that, we've been focusing on compatibility with Amazon IAM, which is their way of managing users with account, groups, users, and integration with Active Directory. So that's what we call the Directory Services Federation. And people who deploy an SDS system, they want to be able to track what the users are doing. So are they consuming too much storage? Are they consuming too many IOPS? So we also developed utilization reporting and management as part of the platform. So it's a focus on multi-tenancy. So this is actually multiple services that we've developed. The first one is the S3 service itself, and this is just the protocol stack. So that talks S3 HTTP on one side, and then talks to a metadata backend and a data backend. We actually made it open source, and that's the S3 server, and we'll talk about that in one of the next talks. We have a Vault service. So Vault is very important. It's the center of all the user authentication, key management, and it's a distributed layer as well, because you don't want to lose that kind of information. And it's connected to the existing directories using IAM and using Directory Federation services. So what this means is you don't have to provision user on our system. You can just connect to your existing directory and give access to the storage system from your existing directory tools. And you don't have to change anything on the storage itself. We have a distributed metadata service because buckets are hard. Buckets can go to billions of entries easily. Some gateway application will upload 64 kilobyte chunks to provide their own file system on top of S3. So we had to focus on having a very fast distributed bucket engine. And so we developed that engine so that it would be easy to geo distribute afterwards. So it's an engine that today we support multiple sites as one large deployment, and the site have to be close by for this engine. And in the future, actually next year, we're going to support deploying this over a WAN, so between two countries like Japan and Paris. And this engine we developed is meant for that. It allows us to easily share a bucket between two sites, have both sites active, and manage the conflict automatically. So IAM itself, so I'd say it's about managing users and their policies. So we have implemented the policies, which is a very large piece of specification from Amazon, where you can go very fine in terms of what the user can do and cannot do. So it's if you look at POSIX ACL, which is a user group others, this is another magnitude more granular. So you can say that, for example, this user can only write on that folder, but never delete or never read. But this other super admin can do anything you want. So you can really modelize a lot of fine-grained granularity into your authentication. And we see a lot of people, especially banks, love having that level of control. We implemented encryption as well, which is that you can automatically encrypt the data going into a bucket. And we integrate with existing key management services. Basically, we didn't want to have to store the keys because the one who stores the keys is responsible for a lot of things. So we integrate with existing appliances and we go talk to them to get a key for a particular object, for example, and transparently decode as we get the information. So this is how we connect to an existing identity provider. So let's say that I have an end user that wants to access our storage, so the S3 connector. He's not going to log in to us. He's going to log in to his enterprise directory. So on Microsoft, it's going to be some website with IIS. Is going to connect to that website and log in. So it could be two-factor authentication. It's all handled at that identity provider level. So maybe it has a token as well, but with us, we're not in the way of the authentication. So we don't even see the password. After it's been authenticated, our Vault database gets updated, and we know that this user has access to a particular resource. And then he can connect to the object store and access the data. If the user has to be revoked because he was fired from the company, if it's removed from the Active Directory, it will be automatically removed from the object storage as well. So that's a seamless integration of authentication.
A question on that: if someone is removed from the company, just thinking because we were talking a lot about legal hold yesterday with another company. So if there's a legal hold or something on that person, so what I need to do is make sure that identity isn't deleted. Otherwise, I lose access to all of the data.
Yeah. So it's only the access credentials that are revoked, but the data is still there.
Okay. So the data, but how would I, so let's say they're fired and leave the company and we revoke their credentials, but I still want to get at the data that they've been creating, like spreadsheets or...
Yeah, so in terms of the way I would do that is with IAM, there's an account, and you can create keys for the account, and these keys can do anything. Okay. Then you have users and everything else. So I will log in as a kind of a super admin, and then I can access anybody's data. Okay. So I was talking about usage reports, so you want to know what group is doing what and things like that. So we have real-time stats and metrics that you can pull via REST API to know what people are doing. It's at the bucket, user, and account level. And you have the management tools. Actually, the good news is it's the AWS tools. Since we implemented the IAM interface, the HTTP APIs, you can use the standard AWS tools, so AWS CLI, that you download from the Amazon Web Service website and point to our system, and you can manage your users this way. So we talked about the metadata engine. The most important thing is we call it a distributed consensus algorithm that has a notion of leader election to manage the bucket metadata. And for buckets, you need to go 1,000 of operations per second because there are appliances that are going to hit very hard the actual S3 buckets. So we developed something that's very fast and keep consistency and can be distributed across site. That's what I was talking about before. That's nothing more on that slide. So everything we do with our DNA from service provider has to scale. So this engine that we developed, the S3 connector, is also fully scale out. So you have containers that are the REST interface, in a way, the S3 server interface. And you have the metadata engine, and you have the actual object store in the backend doing. So if you need more bandwidth, because you're doing encryption of the data, and this is consuming a lot of CPU at that layer because you're doing a lot of SSL, OpenSSL, AES encoding, you can just scale out that layer and add more connectors. And these don't have any state, so you can even start them on a VM. You can even do that on the fly. If you have a sort of traffic, just start new connectors. And you have more CPU, more memory, you can manage more sessions at the same time. Now, if it's a metadata engine problem and your buckets are being hammered, if you need more capacity, you add wing nodes. That's the easy one. And if you have metadata needs, you just scale out the metadata layer itself. And it's going to scale out at all these different layers. So this is to scale with the number of operations. This is to scale with capacity. This is to scale with the number of active users sending you traffic at any given time.
And each of those layers actually are running on the ring nodes.
So yes, absolutely. These two layers typically run on the ring nodes. This one, you may run it on a different layer for security reasons. And also to scale it, it's better to have it on a different layer. Because here you have users accessing, it may be public as well on the internet, and you don't want to share the network between your data and this layer. So it's typically on a different layer for security reasons.
And every one of those elements is effectively a Docker container.
Yeah, so except for the ring nodes. But all these elements are Docker containers.
Future, Ray. You know that, right?
Yeah.
So you're seeing Docker this afternoon, right?
Yeah.
Do you guys support DARE, data at rest, like self-encrypting drives or anything like that for the nodes?
So we don't do it ourselves. Our partners have solutions like HP, for example, that will enable that at the hardware layer. So it doesn't concern us. It's done at the lower end of the stack.
It's at the disk drive level then, or
No, it's not at the disk drive. It's at the controller level.
MSA or something like that? Or the-
Yeah, so we use some SAS adapters, for example, but beyond the SAS adapter
Okay.
itself. Yeah.
Okay, if I have self-encrypting drives, can I use that?
Yeah, absolutely.
Okay.
Yeah. Doesn't make a difference for us. So I want to talk about object and file. So we talked about this new engine for the object protocols, and we're actually going to use it for file, and Vianney will do a demo as well of that. So the bucket is a flat hierarchy of object. So object ABC, another bucket object ABC. It scales very well because of that flat hierarchy. So you don't have to worry about if you delete something, you don't have to update a parent and a parent of a parent and things like that. So it's completely flat. The object themselves, I open a connection, I write it, and I close it. Right? So it's easier to manage than I open a file, keep the file open for days, and do some writes randomly, and sometimes flush, which is what we do in a file system, which are harder to maintain. And so because of being flat and object being written in one shot, it makes it easy to scale to billions of objects. On a file system, you have a hierarchical model. You can write randomly into your files. And so because of that, you don't scale to billion, you scale to hundreds of thousands or to millions because of the overhead. But still, a lot of customers are asking to be able to do S3 and files at the same time. So we've started to develop a prototype just for that, and we're going to do a demo. So it's not available today, it's something we have next year. But we have a working prototype where we can do both file and object at the same time.